Hello everyone. Today we will going to see some practice questions from the chapter Coordination Compounds. This is part 5. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. This is our index slides. We're going to see practice questions from question number 33 to question number 41. Let's start with the question number 33. Among the following, which is not the pi-bonded organometallic compound? We have given some complexes from which we have to identify the one which is not pi-bonded organometallic compound. Options are potassium, platinum, chlorine whole thrice, eta2, C2H4, iron, eta5, C5H5 whole twice, CH3 whole 4 SN, or chromium, eta6, C6H6 whole twice. You have 10 seconds to solve this question. After that, you will see the answer. So the correct answer is option C, that is CH3 whole 4 SN. SN means 10. The organometallic compounds having pi bond between carbon and metal are known as pi bonded organometallic compound. Okay, so there is a pi bonded written here. That means that pi bond is present between the carbon and the metal atom. Eta represents hapticity. For example, eta2 describes a ligand that coordinates through two contiguous atoms. CH3 whole 4 methyl whole 4 SN is not a pi bonded organometallic compound, and in all the other options A, B and D, there is a pi bond between the metal and the carbon. You can see in the first option platinum Cl whole thrice and C2H4 eta2 C2H4, right? So you can see that there is a pi bond between the metal and the carbon chain, right? So basically this bond is between the carbon chain pi bond and the metal. That is why it is counted as the pi bond between the metal and the carbon, and that is why it is a pi bonded organometallic compound. In the option B also there is iron eta5 C5H5 whole twice. You can see that iron is directly attached to these two pentyl rings, right, of carbon. That means there is a pi bond. There is a presence of pi bond between the metal and the carbon ring. In the D option, chromium C6 eta6 C6H6 whole twice. So here also there is a direct bond between the these two carbon chain and the metal, that is chromium. That's why there is a presence of a pi bond. But in CH3 whole 4 SN, the bond between the carbon and the metal is not a pi bond, and that is why this is not a pi bonded organometallic compound. And our question is that which of the following is not the pi bonded organometallic compound, and that is this molecule. The C option is the correct answer. Okay, now let's move on to the next question. Question number 34. Which of the following is an organometallic compound? You have to tell that from the given options which is a organometallic compound. Options are C2H5 zinc C2H5, CH3B OCH3 whole twice, CH3OB OCH3 whole twice, or none of these. You can see that in the A option, the C2H5, that is ethyl group, is directly attached to the zinc 2 times. And in the second option, we have B directly attached to the methyl group and OCH3 group. And in the third option, we have B, directly attached to the OCH3 group thrice. Fourth option is none of these. You have to find out the organometallic compound. You have 10 seconds to think about this question. After that, we will see the answer. Okay, let's see. The correct answer is option A, that is zinc, directly connected to the two ethyl groups. An organometallic compound is the one which contains at least one metal carbon bond, right? So organometallic compound are the compound in which at least one metal and carbon bond should be present. B, that is boron, is neither a metal nor non-metal. It comes under metalloids. So in B, OCH3 whole thrice and CH3B, OCH3 whole twice, there is no carbon atom that linked directly to a metal. There is no bond present between for a metal carbon bond, even at least one in these two compounds. Thus, C2H5, zinc C2H5 is an organometallic compound because you can see there is a direct two bonds between the carbon and the metal atom. Thus, our option A is the correct answer. Okay, now let's move on to the next question. Question number 35. Ferrocene is an example of. So, ferrocene is a compound. We have to tell the example or the word which is correct used for the ferrocene. Like ferrocene is the example of what? Which category? Options are sandwich complex, pi bonded complex, a complex in which all the 5 carbon atoms of cyclopentadiene anion are bonded to the metal, or all of the above. So you have 10 seconds to think about this question. After that, we will see the answer. Let's see. The correct answer is option D, that is all of the above. So ferrocene is an example of all of the above options given in the options. So ferrocene is a sandwich complex compound in which all the 5 carbon atoms of ferropentadiene anions are linked directly to the metal iron by pi bonds. So that is why ferrocene is a sandwich complex. Ferrocene is a pi bonded complex, and ferrocene is having all 5 carbon atoms directly linked to the metal too. So you can explain the ferrocene concept by any of the options using. Okay, this is the structure of ferrocene. Iron is directly connected to the ferropentadiene anions, right? And that's why iron eta5 C5H5 is the ferrocene molecule or the formula of the ferrocene molecule, and it is having every property like it is a sandwich complex, it is a pi bonded complex, it is a complex in which all the 5 carbon atoms are directly linked to the metal. So that is why option D is correct, that is all of the above options are correct. Okay, moving on to the next question. Question number 36. An aqueous solution of an inorganic salt X, when added to an aqueous solution of barium chloride, a precipitate insoluble in dilute HCl is obtained. So we are talking about a reaction going on here between the inorganic salt X and the barium chloride. The product we get will be insoluble in the dilute HCl. Addition of excess of Ki, potassium iodide, to the X gives a brown precipitate which turns white on addition of excess of hypo. With an aqueous solution of potassium ferrocyanate, a chocolate colored precipitate is formed. If you react X with potassium ferrocyanide, a chocolate colored precipitate will form. The X will be what is the X? You have to tell the formula of the X. Options are copper, ammonia whole 4 SO4, copper sulfate dot 5H2O, zinc sulfate dot 5H2O, or AgNO3. You have 10 seconds to think about this question. After that, we will see the answer. Okay, let's see. The correct answer is option B, that is copper sulfate dot 5H2. This is the reaction that copper sulfate dot 5H2, that is X, when reacted with barium chloride, it will give a precipitate which is insoluble in HCl, that is BaSO4, plus cuprous chloride CuCl2. Now, if you react X, that is 2 CuSO4 with potassium iodide Ki in the excess, it will give brown PPT, brown precipitate, which is Cu2I2 plus 2K2SO4 plus I2. Now, when we react the I2 with the 2Na2S2O3, that is hypo, excessive hypo, we will get 2NaI, a white precipitate. That means brown precipitate is converted to white precipitate, plus Na2S4O6. And when X, that is 2CuSO4, is reacted with potassium ferrocyanide, that is K4FeCN6, it is giving us chocolate colored precipitate, which is copper 2 iron CN6 plus 2K2SO4. Right? So all the reactions are correct. And after looking all these reactions, you can say that X is nothing but this compound present in the option B, CuSO4.5H2O, and thus B option is the correct answer. Okay, moving on to the next question. Question number 37. The equation which is balanced and represents the correct products is. Options are Li2O plus 2KCl giving us 2LiCl plus K2O, COCl NH3 whole 5 whole positive plus 5H positive giving us cobalt 2 positive plus 5NH4 positive plus Cl negative, MgH2O6 whole 2 positive, here it will be bracket, okay, MgH2O whole 6 whole 2 positive plus EDTA whole 4 negative at the presence of excess NaOH giving us magnesium EDTA whole 2 positive plus 6H2O, or copper sulfate plus 4 KCN giving us K2 copper CN whole 4 plus K2SO4. You have to tell that which reaction is balanced as well as represents the correct products. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option B, that is COCl NH3 whole 5 whole positive plus 5H positive giving us CO2 positive plus 5NH4 positive plus Cl negative. According to the A option, Li2O, which is a weak base, plus 2 KCl giving us 2 LiCl plus K2O, which is a strong base. You can say that this is wrong equation, since a stronger base K2O cannot be generated by a weaker base Li2O. That is why this equation is wrong. According to the B option, COCl NH3 whole 5 H whole positive plus 5H positive giving us cobalt 2 positive plus 5NH4 positive plus Cl negative. This is correct. All amine complexes can be destroyed by adding the H positive ion, and hence on adding acid to COCl NH3 whole 5, it gets converted to cobalt 2 positive, NH4 positive and Cl negative. So that means our complex is destroyed by adding H positive ions from the acid. That is why this is correct equation. If you see The third option, C, it is given MgH2O whole 6 2 positive plus EDTA whole 4 negative. In the presence of NaOH or OH negative excess amount, we will get MgEDTA whole 2 positive plus 6H2. This is a wrong equation since the formula of the complex must be MgEDTA whole 2 negative, not MgEDTA whole 2 positive. According to the D option, the fourth reaction is incorrect. It can be correctly represented as 2 copper sulfate plus 10 KCN, giving us 2 potassium whole thrice, copper CN whole 4 plus 2 K2SO4 plus CN whole twice, which is a gas. So these are the correct explanations for every option given in this question. And after looking every option explanation, we conclude that B, the reaction given in the B option, is the correct reaction. And thus our B option is the correct answer. Okay, let's move on to the next question. Question number 38. Which of the following statements is incorrect? We have given some statements in the option. We have to tell which is incorrect. Fe3 positive ion also gives blood red color with SCN negative ion. Fe3 plus ion gives red color with SCN minus ion. On passing H2S into Na2 zinc oxide solution, a white PPT of zinc sulfide is formed. Or cupric ion reacts with excess of ammonia solution to give deep blue color of the copper NH3 whole 4 2 positive ion. So you have to tell that which statements from these 4 options is incorrect. You have 10 seconds to think about this question. After that, we will see the answer. Okay, let's see. The correct answer is option A, that is iron 3 positive ion also gives blood red color with SCN negative ion. This is the incorrect statement. So if you add the iron in the 3 positive state in SCN negative, it will give this complex FeSCN whole 2 positive. It is red in color, not blood red, right? That's why the option A statement, which is saying that Fe3 positive ion also gives blood red color with SCN negative ion, is incorrect. And all the other given statements are correct. And we have to find the incorrect statement. That is why option A is the correct answer. Okay, let's move on to the next question. Question number 39. We have given assertion and reason. Assertion is chromium H2O whole 6 Cl2 and iron H2O whole 6 Cl2 are reducing in nature. Reason: chelate complexes tend to be more stable. Options are assertion and reason both are correct statements, and reason is correct explanation of assertion. Assertion and reason both are correct statements, but reason is not the correct explanation of assertion. Assertion is correct, reason is incorrect, or both assertion and reason are incorrect. You have to select the correct option. You have 10 seconds to think about this question. After that, we will see the answer. Okay. Now, the correct answer is option B, that is assertion and reason both are the correct statements, but reason is not the correct explanation for the assertion. So what will be the correct explanation then? It is that chromium in the given complex chromium H2O whole 6 Cl2 is present as Cr2 positive. If you look at the oxidation states for the chromium in this complex, H2 is having 0, so 6 times 0 will be 0, plus Cl will having 1 minus 1, but Cl is 2, so 2 times minus 1 will be minus 2. So x minus 2 is equals to 0, x will be plus 2. So chromium is in plus 2 oxidation state, which undergo oxidation to chromium 3 positive. And Iron in the complex iron H2 whole 6 Cl2 is present again as Fe2 positive, which can undergo oxidation to Fe3 positive, right? So H2 is a weak field ligand in both. That is why pairing will not happen. And you can see that second statement, that is reason chelate complexes tend to be more stable, is also a correct statement. And the first statement that chromium H2 whole 6 Cl2 and iron H2 whole 6 Cl2 are reducing in nature is also correct. You can see that they are oxidizing, right? Reducing in nature means they are reduction potential, or they are reducing agents. They reduce the others and get oxidized itself. So that's why they are reducing in nature. So both the statements are correct, but the region is not correct explanation for the assertion given. That is why B option is the correct answer. Okay, let's move on to the next question. Question number 40. Each of these questions contain two statements. Statement 1, assertion, and statement 2, region. Each of these questions also has 4 alternative choices, only one of which is correct answer. You have to select one of the codes A, B, C, and D given below. Statement 1 is iron H2 whole 5 NO SO4 is paramagnetic. Statement 2 is the iron in Fe H2O whole 5 NO SO4 has 3 unpaired electrons in total. Options are statement 1 is true, statement 2 is true, statement 2 is a correct explanation for statement 1. Statement 1 is true, statement 2 is true, statement 2 is not a correct explanation for statement 1. Statement 1 is true, statement 2 is false, or statement 1 is false, statement 2 is true. You have 10 seconds to think about this question. After that, we will see the answer. Okay, let's see. The correct answer is option A, that is statement 1 and true both are correct, and statement 2 is correct explanation for the statement 1 given. So in the complex iron H2 whole 5 NO SO4, let's suppose that oxidation of iron be X. Now if you calculate for the X, it will be X plus 5 times 0 plus 1, because N is having charge or oxidation state as plus 1, plus SO minus 2 for SO4 is equals to 0. Now you solve this equation for X, it will be X is equals to plus 1. That means Fe, iron is having plus 1 charge, and for iron plus 1, the noble gas configuration is argon 3d6 4s1. Okay. As NO positive is a strong ligand, causes pairing of 4s electron. Thus the configuration is 3d7, because the 1 electron in the 4s will get into the pairing in the 3d orbital, and 3d6 will become 3d7, and the unpaired electrons will remain as 3. Currently 3d6, that means there are 5 subshells in the 3d orbital, right? If you fill each one with 1 electron, and 6 is in total, so one subshell will get in pair, but 4 subshell will get unpaired. But as NO is a strong field ligand, not that much strong, but it is count in the strong field ligand. So only in the 4s1 the pairing will happen. So that 4s1 electron will go into the 3d 6 electron system, and now 2 subshells will get paired. Only 3 subshell will remain as unpaired. That is why the total number of unpaired electrons we get is 3. So statement 1, that this complex is paramagnetic, is correct due to the presence of unpaired electrons, and the iron in this complex is having 3 unpaired electrons. This is also correct. And the statement 2 is correct explanation for the paramagnetic nature for the complex. That is statement 1. Thus our A option is the correct answer. Okay, let's move on to the next question. Question number 41. Again, we have a statement 1 and 2. We have to select the correct option. Statement 1 is the geometrical isomers of the complex MnH3 whole 4 Cl2 are optically inactive. Statement 2 is Both geometrical isomers of complex MnH3 whole for Cl2 possesses excess of symmetry. Options are statement 1 is true, statement 2 is true, statement 2 is the correct explanation for statement 1. Statement 1 is true, statement 2 is true, statement 2 is not correct explanation for statement 1. Statement 1 is true, statement 2 is false, or statement 1 is false, statement 2 is true. You have 10 seconds to think about this question. After that, we will see the answer. Okay, let's see. So the correct answer is option A, that both the statements are true, and statement 2 is correct explanation for statement 1. Both cis and trans forms of the complex MnH3 whole for Cl2 are optically inactive. There are plane of symmetry. In addition to that, there is alternate axis of symmetry, which makes them optically inactive, because for the optically active compound, the symmetry should not be present. But if you see in the cis and the trans form of the given complex, there is a plane of symmetry coming and the alternate axis of symmetry is coming. Right? That is why due to these regions, due to the presence of these types of symmetry, the complex given are optically inactive, and because of the presence of the symmetry or the plane of symmetry or the axis of symmetry in these two complexes, in these two isomers of the given complex. Thus, you can say that statement 1 and 2 both are correct, and that statement 2 is correct explanation for the first statement. Thus, our A option is the correct answer. Thank you.